Okay, so for this version of this test, we need to see, I see horizontal asymptote. I don't see any kind of like this. It isn't like it's a rational function because there's nothing for this graph over here. So that tells me it's not a rational function. It isn't like this is a vertical asymptote, because if it were, it would be, and I know it's not a log function because log functions don't have horizontal asymptotes. Log functions have vertical asymptotes. So what am I seeing? I'm seeing that this exponential function is shifted up to 4. So no, that's y equals ab to the x plus 4. And then I see it passes through the point 0, 2. So 2 equals a times b to the 0 plus 4. I'll subtract 4, and then b to the 0 is 1. So that tells me a equals -2. So now I got to find b. I know this, let's see, this should be -2 on the paper I gave you in the test. I fixed that. So -2 equals, and I just found out that a is -2, and I don't know what b is yet. And I know x is -1 plus 4. So now if I solve this for b, I'm going to subtract 4. I get -6 equals -2. And that b to the -1 is kind of a pain. So I'm going to write it as a positive exponent by taking the reciprocal, right? Writing it as 1 over b, kicking it downstairs. Now if we do the cross products, I get b equals 1/3. And that's all I need to finish this equation. I know this graph can be represented by the equation y equals -2 times 1/3 raised to the x plus 4. Okay, then for that next one, you should stop that and write that down if you haven't yet. Okay, so then for the next one, I see a polynomial function. I know that it's acting like x to the 4th or x to the 6th or something like that. It's certainly a even power. So, and I told you on the test that this is the same as, let's see, that's 5 1/3, which that's 16 thirds. So that y-intercept is 16 over 3, 0, 16 over 3. We'll use that in a minute. I see this graph wiggles through that 0 at -2. So I'm going to write x plus 2 cubed. I don't see anything special happening at -1, so I'm just going to write as x plus 1. And then it bounces at x equals 1, so that's going to be x minus 1, but I got to square it. So I did all the zeros. Now, probably there's a stretch factor there, so I'm going to say 16 over 3 is y. And since it's a y-intercept, I know x is 0, so every place I see an x in this equation, I'm going to replace it with 0. And so 0 plus 2 is 2. Cube it, you get 8. And 0 plus 1 is 1, of course. And 0 minus 1 is -1. But if I square it, it turns to +1. So then that really becomes 16 over 3 equals 8a. If I divide by 8, or I could think about it as multiplying by 1 over 8. That might almost be easier in this case. And here I can see I can cross cancel an 8 out. So that's 2. That's 1. So that becomes a equals 2/3. And it opens up, so I know it's positive. So that's that polynomial. Okay, the next one I see some vertical asymptotes. I see this is there's a vertical asymptote at what? Let's see, 1, 2, 3. And there's a vertical asymptote at -3. And I see a horizontal asymptote, so that tells me it's going to be the same power. I see some zeros at -1, and that doesn't look special, but at x equals 2, it looks like it bounces. So let's do some setting up here. I know vertical asymptotes happen in the denominator because I can't divide by 0. And I know that this is at x equals -3. So I'm going to write x plus 3. And I see the other ones happen at +3. That's going to be x minus 3. But what's so special about the x at the vertical asymptote at x equals -3? Both this graph heads to the same direction in both areas. So that tells me it's just a transformation of 1 over x squared. So I need to here, let me get fancy, put it with red. This needs to be squared. Okay. Now let's come back to blue. Now for the numerator, for the zeros, I see it crosses the x-axis at -1, and it doesn't look like it's doing anything fancy. It's not bouncing or wiggling through it. So I'm just going to write x plus 1. But it is bouncing it as x equals 2, so that's acting like the parabola. So squared. And now I see the same power, right? X cubed over x cubed. So that tells me I can just write that that horizontal asymptote in without doing anything fancy. Let's see, what is that? At 2. So I'm just going to stick 2 there. I'm done. That represents that polynomial, or that rational function. Let's clear that drawing. I see a parabola, so that tells me it's quadratic. I see the vertex is -1, -3, -1. So I know y equals maybe some stretch factor, x plus 3, and we get to square it because it's, and then -1. Now let's see if there's a stretch factor that's other than 1. I see that point, -2, -3. So -3 equals, I don't know, times, well, let's see, -2 plus 3 is 1. Square it -1. So 1 squared is 1, and then I'm going to add 1. So a is -2. And it opened down, so I know that should be negative. So that's that equation. Easy enough. This next graph, I am seeing a vertical asymptote. And I don't see, now how do I know that it's not, a register rational function? Well, I don't see this graph that isn't, if it's a rational function, see up here at this one, see how there's, aside from the vertical asymptotes, this function is graphed over a lot bigger domain. It isn't just stopped. So this one is stopped. It stops. We don't see any graph over here. So that vertical asymptote, and there's nothing over here, that tells me this is a log function. So to get that log function, let's see. I see there's a vertical asymptote at -1. So I know it's going to be log of x minus 1. But I also see normally log functions look like this. So not only has this been flipped around the x-axis, it's also been reflected around the y-axis. And back when we did this, we learned, okay, if the y-axis, you're going to take care of that. So I'm going to make the inside negative. Change that to that. Remember, when it's inside the argument, that reflects the function around the y-axis. So we could write this as, let me come back to blue. We could just write this as log of -x plus 1, and that'll make our later work later. And of course, we got it better. So of course, we should have, there's probably some k, or maybe not some k, and then maybe there's some stretch factor. So let's do some elimination here. So if I look at this point here, -2, 0, well, let's plug that in, is 0 equal to some stretch factor times the log of, let's see, negative, if I use this version of it, -2 plus 1 plus k, well, let's see, -2 is going to be, no, something's not right here, just a minute. Right here, I screwed up. This should be plus because it shifted left 1, which would make this negative. You probably already caught that one by mistake. And that would make this, that would keep this, let's see, -1. Yeah, -2, let's see, that's negative. -1 times -2 is 2, minus 1 is 1. What's the log of 1? 0. So that means 0 times a is 0. That tells me k is also equal to 0. Whew, that was confusing. Okay, let me clean some of this up. So you're okay with why I wrote that as plus 1? Because this shifted left 1, I should have written this as log of x plus 1, and then because it's been reflected around the y-axis, I should have written this as y equals a times the log of -x minus 1. And of course, we just found out k was 0. So now I'm going to pick this other point, -2, -5, to find the stretch factor. So -2 equals, I don't know, times the log of, let's see, -5 turns to +5 minus 1. Well, isn't that -2 equals a times the log of 4? So a would have to equal -2 over log 4. And so to finish this off here, I'm going to come over here. Y equals -2 over the log of 4 times the log of -x minus 1. So that's that log function. This was sufficient. If this were a multiple choice question, one thing that might happen is this. We did some of this in our work in the notebook. Log 4 is the same as log 2 squared, right? And because we can bring the 2 down in front because it's an exponent using that log property, the exponent log property, I could do this as 2 log 2, and then that 2 would cancel off. So we could just have written this as -1 over the log of 2, and then we could even kick it further down the road since this is times, here, let me erase this. This is times the log of -x minus 1. Log of this divided by log of the 2 is the change base formula. So we could have just written this as log base 2 of -x minus 1. And then, of course, we have that -1 out in front of it. Okay, so that would have been a simplification, but this is all you needed to show me. Next question. So then we're going to do the domain of this function. Well, I know the zeros. I know it's equal to 0 at x equals -3, right? And I know it's 0 at x equals 1. So we're going to make a little number line. We're going to mark -3. We're going to mark 1. We're going to pick a number that's less than -3, like, I don't know, -10. Well, if I drop in -10, isn't that going to be -7 squared times -11? Well, a negative number squared is positive. Times a negative number will be negative. So that it's underneath the radical is going to be negative. Then I'm going to pick a number between -3 and 0. All right, -3 and 1. 0 certainly works. So if we drop in 0, doesn't that give me +3 squared times -1? Well, that's also negative. And then if I pick a positive number, everything's positive. So the actual domain of this is going to be from 1 to infinity. And now some people on the exam also commented, well, because it can be, if x equals -3, I can drop in -3 and get the square root of 0. So technically that is a solution. We're usually concerned about where this is continuous. So, I mean, if we were to graph this, you know, whatever it looks like, I might see some point here, but the rest of the graph would be all over here doing something, whatever it looks like, you know. But so that one point, yes, technically it's in the domain, but it's not really it's not an important piece. Okay, then we've got this Old Orchard Beach problem. I think I changed some of this. Here, let me pause this video because I did change this. No, actually, this is the change value. Okay, how high is the bagel at the time she releases it? Well, that's at time 0. So h of 0, well, if I drop 0 into everything, I just get 10. And many of you commented that's the y-intercept. It is. It's in time. That's the height at time 0, and this is what, meters? Yes, that's 10 meters. Then to find how the maximum height, well, that, because this is a parabola that opens down, because that leading coefficient is negative, I know the vertex will be the maximum height. And some of you graphed it and did it that way, and sure, that is one way to do it, except I was looking at the analysis. So you've got to remember that formula that says x or t equals -b over 2 times a, which is the x coordinate in the vertex. In other words, and that's when it'll reach the highest. So if I look at this problem, I see -4.6 divided by 2 times -4.9. And if we do that math, let's see, and I did this once already. Maybe I should stop this video and go get my work. Here, let me more pause. So I got this to be equal to, at time 0 equals 0.47. And that's probably about right for somebody winging a bagel off the pier. I didn't make it up to be right, but that's a pretty reasonable. About a half a second will reach max. And then to find the maximum height, so that's when it happens, that's seconds. And then when it happens, we're just going to drop that into the equation, 0.47. And that means every place you're going to evaluate this function. I mean, I guess I'll write it out for you since I'm trying to get you to understand how to do this. So 0.47 squared plus 4.6 times 0.47 plus 10. And if you value that with a calculator, I got 9.4 feet. Or 9.4 meters, right? Isn't it meters? Yeah. That doesn't make sense because it's got to be more than 10. Just a minute here. I did something wrong here. So it's 11.1, and that makes sense. I must have typed something in wrong. So it's 11.1 meters. It had to be bigger than 10 because I know this. It started here at 10 and it went up like that for the maximum. Okay, so that's the maximum. And then how long does it take the bagel to splash down the ocean? Well, let's see. Let's clear my writing here. What I'm doing is I'm solving this equation, the h of t. I'm looking for where is that equal to 0. So where does 0 equal negative 4.9 t squared plus 4.6 t plus 10. Now, some of you try to do some solving for this, moving numbers around. This is a quadratic equation. We have 3 ways to solve a quadratic equation. One of them is to set it, first off, you got to set it equal to 0. Then you try to factor it. This doesn't factor. You could use completing the square. Nobody does that. The other solution is the quadratic formula. Now, I told you guys, and we've been doing this all year, you do not have to set up the quadratic formula for this. I know this is going to have real number solutions. There's not going to be any imaginary numbers here because I know this parabola, it starts up here, goes up, and I know it's going to splash down. It isn't going to never splash down. So use quad 83 or a polynomial solver. So all you need to remember is that A equals negative 4.9, B equals 4.6, C equals 10. Now, I don't know what you have for a solver, whether you're using a calculator, a graphing calculator, or using something on your phone. Let me fire up my graphing calculator here, and I'll show you how to use that graphing calculator. Okay, so on one of these graphing calculators in my class, or if you own one, you're going to press Program. It should see Quad 83. On my classroom calculators, there's a couple other programs. On this one, it's just one Quad 83. And you press Enter and press Enter again. And then it starts running. It prompts you, well, what's A? Well, A is negative 4.9. You press Enter. What's B? 4.6 in this case. What's C in this case? Well, 10. And it gives me the answers, and I'm going to ignore the negative answer because I can't go backwards in time. So when t equals 1.97, this bagel touches down. And that would be the answer to, and so all I was looking for was you to do h of t equals 0, and then you can come up with the answer, whether you use a graph or you didn't have to do the quadratic formula for this. That's why I said you don't have to show the quadratic formula. Okay, so now let's come back here and try this. I think is that it for this question? Yes, it is. Okay, so that's the first video.